Hello friends, in this video we will learn about how Planck's constant is determined by the graph that we have drawn in photoelectric effect. This is the graph of stopping potential versus frequency. You know, we have already drawn this graph as we change the frequency. So the stopping potential keeps on increasing. Okay, this part was not there in the previous graph. I will come to it later on. Wow, how do we determine this Planck's constant? First of all, keep a notice of this graph and Einstein's photoelectric equation. H nu is equals to work function plus EV0. I am rewriting this equation in some other form. See, EV0 is equals to H nu minus W0. W0 को यहाँ पे ले गया. Okay, work function को यहाँ पे ले गया. Then dividing everything by E, what I get is H upon E into nu minus W0, W0 upon E. Now this equation is compared to the linear equation. Y is equals to mx plus c. Where we have y-axis, we should have stopping potential. This is the y-axis. Is this for stopping potential? Yes. Where we have nu. On x-axis, what should we have? Frequency. So is x-axis therefore frequency? Yes, this is not mu 0, this is simply mu. Okay, changing the frequencies. So now these two equations can be compared. And instead of m, what is here in this equation? It is h upon e. So can I write that m is equals to h upon e? Do you know what this m is? This m is the slope. And do you also know that slope is equals to tan theta? If you know this value of theta, you can easily find the value of tan theta. So h is equals to tan theta into e. यहाँ से लेंगे h upon e is equals to tan theta. So tan theta into e will give you the value of h. Again, instead of tan theta, you can also write the slope of this line. What is the slope of this line? It is AB upon BC. So Planck's constant can be determined this easily. You know what is the value of Planck's constant? 6.63 into 10 to the power minus 34 joule into seconds. Okay, there is one more thing that can be achieved from this graph, and that is to find the work function of a given metal. For that we have to do something which is known as extrapolation. Extrapolation का मतलब होता है ग्राफ को उस जगह लेके जाना जहां पे वो अदरवाइज रियलिटी में नहीं गया है. So we extrapolate this graph, we extend this graph up to y-axis. That means up to the axis of stopping potential. Okay, and we find this y-intercept. ये जो y-intercept है ये हम find करेंगे इसका. Okay, so what is exactly y-intercept of a straight line? The y-intercept of a straight line is when its x-coordinate becomes 0. Okay, so y-intercept of this graph is at x equals to 0. x की जगह क्या है यहाँ पे? Instead of x we have frequency. So you make the frequency equals to 0 in that equation. In this equation, make frequency is equals to 0. So what is V0? It is minus W0 upon E. So what is W0? The work function. It is equals to minus EV0. Okay, but now you also know that this y-intercept, what is the y-intercept? It is minus W0 upon E. So can I write the y-intercept as OP, which is equals to minus W0 upon E? So OP will be minus W0 upon E, and from here you can find out W0 or W0 is equals to minus E into OP. यानी ये measure करेंगे, इसको आप E से multiply करेंगे, and that will be equal to the work function of the metal. Okay, this is a very important question because from this graph we can actually find the value of Planck's constant. पहले भी इस experiment से पहले भी Planck's constant की values find की गई थी, but that were not so accurate. This graph will give you a valid and more accurate value of Planck's constant.